Welcome to Rational Science. Today I start the class by dealing with inventions and inventors. And I start the class with a couple of questions. Who invented fire? Well, if you ask the Greeks, they would say it was Prometheus. And he came down from he came down from the Olympus, Mount Olympus, and gave fire to man. Okay, and it was Zeus who punished him by having an eagle eat his liver or his guts for an eternity. Okay, for doing that deed. Fire was supposed to belong only to the gods, but there's something wrong with that fable, that theory. And I guess the Greeks never figured it out because fire had been around already before man. Okay, they should have figured that out because you have natural fires, fires that get started by Mother Nature herself, or Zeus throwing his his bolt and creating a forest fire or a jungle fire or whatever. And so when you trace it, you find out that fire's been around at least 470 million years ago, since 470 million years ago, since the Ordovician. Now, you don't have to believe that date because those dates are very flimsy, but for sure, fire has been around before man. Okay, because again, many fires start by nature, by lightning hitting maybe some dry leaves or whatever, and you have fire. So man discovered fire. Man did not invent fire. Okay, he ran into, like I keep saying, it's like when you discover the wall because you ran into the wall, and so what should they do? What should you claim that? Oh, I invented the wall or I discovered the wall. Yeah, because you bumped into it, not because you broke your head trying to invent a wall and trying to devise a wall. And the same thing with fire. Fire, man bumped against, saw it. And the genius part, the inventive part was sticking a stick in there, pulling it out, and using it as a defense against other animals and maybe, hardening tools and cooking meat or whatever they used it for in the old days. Okay, how about the spear? Spear's been one of the longest standing weapons we've ever had, together maybe with fire and the hammer, right? And I'm not sure you could distinguish between a hammer and a knife, because one is sharp and the other one is dull, but they use these stones to hit things, okay? But then at some point they invented the spear, okay? And here's a couple of spears that they found, okay? They look more or less like this. These are maybe among the oldest spears out there. And some of these date to about 400,000 years ago. Some say there were spears already 500,000 years ago. Okay, and in comparison, the knife, the one the stone knife hitting something with a sharp edge, that was there for about 2.5 million years ago. So Homo habilis used that, so those are old artifacts. Okay, how about clothes? I mean, here we wear clothes, right, today. And who invented clothes? Well, one of the funny ones is that they always paint Neanderthal with clothes. And he looks more or less like this. Went on the other side. Got a new mouse and I'm not used to it yet. Okay, so they always paint them, or they dress them up in clothes. And the question is, is it because Hollywood actors don't want to go nude on stage when they do Neanderthal parts? I think the Neanderthals were more like the guy on the right, which was the one drawn by Boulay, 1909? And I think Neanderthal did not use clothes. And the reason I think that is that his ancestors were around England. They found two-legged creatures in England 800,000 years ago. Supposedly, whoever those were and whoever was in France and in Germany at the time, two-legged creatures, they gave rise first to man of Heidelberg, and then to Neanderthal, which came like maybe anywhere from 300 to 500,000 years ago. And so we're talking about 800,000 years ago. Were clothes around then? And so we had these two-legged creatures in England during the glacier times, right? Because you had these glaciers that were stretched all the way to England. So the England was like Arctic weather at the time. And so, yeah, if you have Arctic weather and you have no clothes, then that means man or some hominid got used to the cold in Northern Europe. And that's where Neanderthal came, and I'm sure he did not use clothes. There's no indication that there were needles used by Neanderthal. We haven't found anything like a needle. And we found no clothes, obviously. Now, people say, well, those things deteriorate over time, and so you shouldn't be able to find them. I don't think they ever used clothes at all. They had no need for it. They were like wolves today. You know, they sleep in the snow. And so why can't a monkey also sleep in the snow? Is the cold weather only reserved for mastodons and mammoths and wolves and bears? Can't be a monkey? And so, yeah, I don't think Neanderthal used clothes, and that must have been a distinguishing feature when humans came into Europe, assuming they met. They would have recognized each other as different species just by the clothes, let alone, you know, their appearance, other appearance. I don't think they ever met after, you know, even then. I think Neanderthals disappeared about 40,000 years ago, and humans, the first indication we have of the appearance of humans, in other words, we have a skeleton, right, dates to 35,000 years ago, and that was in Romania. Okay, so Pestera Ku O Ace is the cave, and they found a human there 35,000 years ago, and you know, Neanderthals, for what they see as far as the Mousterian technology, he disappeared 40,000 years ago, 5,000 years before humans entered Europe. So I don't think they ever met. And if any human really ventured into Europe, I'm sure the clansmen would have liquidated them. So that's maybe why we never see any humans in Europe until the Neanderthals are gone. Some people believe they made it. And that's the reigning theory today. Okay. How about the wheel? When did the wheel come into being? Well, for sure, Upper Paleolithic, you have no wheels. You don't have the wheel until the Neolithic, less than 10,000 years ago, okay? And so here's who it's ascribed to or attributed to today. It's attributed to the Sumerians. And I'm sure it probably preceded the Sumerians themselves, but essentially they figured this out because of the potter's wheel. Okay, they had to turn the pot around while they were molding it, and from there they probably realized that the wheel could be used to put on a cart if they wanted to pull it with some horses or donkeys or whatever they domesticated at the time. And I think that's how the wheel came into being. Then they used it obviously for chariots in wars and so on. But the oldest wheel that we've found is Sumerians, and maybe you're talking about, I don't know, maybe 3,500 years before Christ or something along those lines. Okay, and certainly the Egyptians around the same time had the wheel a little later, but you're talking about, again, maybe 3,000 to 4,500 years ago. Somewhere in between there, they had the wheel on carts. Okay, so what is an invention? Let's find out by making a little trip. We're going to go on a trip, time travel. we're going to play an Einstein here. We're going to go in time travel, go through the time tunnel, and we're going to go see some Neanderthals, okay? And we're going to meet this fellow. His name is Org. And Org's going to go to the patent office to patent his new invention, okay? So here's Org, okay? So Org goes to the patent office, okay? And when the worker there says, hi, Org, what do you come here for? Says, I'm going to patent this thing. And what is that? Well, it's a club. Club, huh? What do you use it for? Well, I use it to bop other Neanderthals over the head of the neighboring clan. And I also sometimes use it on my wife. And it works wonders. Says, okay, I'll grant you patent number 3. Okay? Looks like a good device that you could use there. Okay, there you go. Next day, another fellow comes in. And his name is Gore. So Gore goes in there and patent clerk says, okay, what do you got, Gore? I have board. Board? What is board? Well, board is, I use it to hit 2 Neanderthals over the head, to bop them over the head with. Works wonders. Okay, it sounds like a useful device. Okay, you get patent number 4. Okay, so we had 2 patents now, okay, aside from the earlier 2. Next day, another guy comes in. His name is Tron. Okay, say, hey Tron, what do you got there? Well, I've got this device which I made. I took Gore's idea, and I took also the other fella, Org, and I built this thing. I put 4 of these clubs underneath this board, and this is the device. This is the device I have. So, what do you use that for? Well, I use it to bop people over the head with. But see, it's much better than handling just a board from your hands. You can grab it by any one of the legs and swing it around and bop people over the head with. Okay, I'll grant you patent number 5. Okay, okay. The next day we have another fellow. He's from the new generation. Okay, and unlike these guys, he's got a double syllable name. Okay, so he's known as Loon Boy. He comes in there and he says, I've invented this. What is that? Sounds like the same device that this other fella came in with yesterday. And said, well, I call it table. Table? What is table? Said, well, you can put your meals on the table and eat from the table. And you can also use a smaller one and you can sit on it and we call it chair. Yeah, but we already have table and chair. We use them every day. They are made of stone. We are stone people. We are in the Stone Age. We don't use wooden things. Well, to make a long story short, he doesn't grant a patent to Loon Boy. Okay? And the main reason he doesn't, one of them is that it was not really an invention. It's the same thing that the other guy invented, but he just did something different with it. There was no new device. He just used it for something else. That was one of the issues. And the other one was this. It didn't work. When they put their mammoth steak on it, it broke the table. And they said, well, we can't use this, not for our mammoth steaks. And so, he didn't grant it because of that. But we have an issue here. And the issue is, did Loon Boy have an invention or an innovation? And there's a difference, okay? And here we look at the definitions. We find in the both in the Wikipedia and the dictionary, and here you see them, okay? What is an invention? Well, or what is it to invent? It says to originate or create as a product of one's own ingenuity, experimentation, or contrivance. Well, what are we talking about? Are we just talking about ideas? Because if you're just going to create, and then it says product, and what do we mean by product? Are we talking about a solid thing like a gadget, a thing, or are we talking about ideas? Just, for example, methods, processes. And so this is more or less like we just had Loon Boy. He came up with the same thing, but he's using it for something else. That's all he did. Is he going to patent that table and saying I invented table? Simply because he took the same device and just turned it over and said I have a different device. Okay, so we have to distinguish between, I guess, an invention and an innovation, a new use for that same invention, same gadget. Okay, Wikipedia has invention, a unique or novel device, method, composition, or process. It may be an improvement upon a machine or product or a new process for creating an object or a result. An invention that achieves a completely unique function. And this is what happens when people don't know how to define words scientifically, because there's so much gray in there. So much gray. It's got to be black and white if you're going to use it scientifically. But when you have so much gray, then people have different opinions, end up with different opinions on what an invention is and whether you have an innovation over an existing invention or just a cosmetic modification or whatever, So we have to distinguish. We've got to find out what an invention really is. Okay? And what is an innovation? It says something new or different introduced. Something new. A new idea, how to cook maybe. Cook maybe, soup differently. Bake a cake differently. Is that what innovation is? Or is it creating a new thing? Okay. And Wikipedia says innovation, the carrying out of new combinations, Okay? That include the introduction of new goods, new methods of production, the opening of new markets, the conquest of new sources of supply, and the carrying out of a new organization of any industry. Personally, I don't know what business has to do with innovation, especially in regards to the word as it is used in terms of patents or in terms of gadgets. Okay? Now, I worked in the industry, semiconductor industry, for many years as a process engineer. And one of our functions was to write specs. You have to change specs constantly. In fact, I would say that maybe on an average, I had to write a spec, modify a spec, about maybe once a week on the average. You have many specs for different machines. Sometimes you get a new machine in. Sometimes there's a new process. Sometimes you adjust the control limits. There's all kinds of things going on. And maybe on the average, I would say that I had to change the spec, one spec of my portfolio once a week on the average. I think that was the same for all engineers. And if every time I change the spec, you're going to say, oh, you invented something new. That's not an innovation, that's an invention. Man, I should be given a bunch of patents for inventions, okay? And one thing you should be aware of, and I'm an expert in it, believe me, I had to copy these specs to distribute them. Why? Because the companies I work for, Intel and AMD, Advanced Micro Devices, the semiconductor chip companies, right? They do not patent their processes, their methods. And, they're not the only company. I mean, you have companies like Coca-Cola. Coca-Cola, my father worked for Coca-Cola. And Coca-Cola never patented its process for making Coca-Cola. And they've had it since the 1800s, 1890, 1880s, I think it was. They invented Coca-Cola. Okay? And the reason Coca-Cola doesn't patent it is a totally different reason than these chip companies. Chip companies don't patent because they don't want the competition, or especially other countries, from copying their processes. Coca-Cola is not interested so much in that. What they're interested in is something else. It's a selling point. They say, look, anybody out there who says they manufacture Coca-Cola, that they also produce Coca-Cola, they're wrong, because they don't know how we manufacture, how we produce Coca-Cola. They don't know the process. They don't know the method. Why? Because we've never patented it. And by not patenting it, you don't have protection, but they don't want protection. Their protection is their word that they have a unique product because nobody can copy it because nobody knows how they make it. That's their slogan, that's their theory, that's their way of thinking. And so a lot of companies don't patent their processes. And semiconductor companies, again, I cannot imagine them patenting their processes because, like I said, I change the spec, one spec at least once a week on an average, and I wasn't the only engineer. There were other engineers also changing their processes like on a regular basis. And what are you going to do? Patent every time someone makes a change in the spec? So this is where the problem is. They can't keep it's an ongoing process to change specs and to change the process. And you're not going to patent every time you change the process because it changes almost every day from one region of the area, fabrication area to another. So the question is whether processes, methods, have anything to do with patents. Now, the Patent Office does accept patents for processes. Okay, they do accept that. The question is whether that makes any sense. And yeah, I mean, there's no other place to take your process. Maybe to the Copyright Office. Instead of patenting, you copyright. I don't know. The issue here is whether an invention has to do with a process or whether it just has to do with a new gadget, a new device. Okay, and I think that's where we should limit inventions and inventing. Okay, but that's my take on that. Okay, again, that's for the politicians to figure out what version of patenting they wish to pursue. Okay, I'm raising this because there were some people left behind in the Nobel world. Okay, and I'm going to tie some loose ends today on those people. Okay, and the question again whether they invented something or whether they made innovations, cosmetic maybe changes to an existing product. Okay, and so the first issue here is whether I raised this issue a couple of weeks ago, whether ideas are unlimited. And I'm sure a lot of people will argue, or most people will argue, that ideas are unlimited, and I think that's because they never thought about that in any way. But we could spend all day arguing on whether ideas are unlimited. The question is whether inventions, which is a subset of ideas, whether those are unlimited. And so the question is whether if you pull the last marble out of the bag, there's any more marbles in there. Is the bag a bottomless pit where you can just draw inventions forever, or are inventions limited to a point where once you pull that last marble, there's no more marbles in there? That's going to be the issue here, okay? So keep that in mind. And I'm sure a lot of people would like to argue the contrary points. Okay, so I know I'm in the minority here. Okay, so here are the folks that got Nobels for inventing things, okay? And I covered some of these in the past, but I'll just run through them relatively quickly. You've got Albert Michelson for his optical precision instruments, specifically the interferometer, okay? You have Gabriel Lippmann a year later. Again, these are the first 20 years of the Nobel Prize. They gave at least five Nobels for inventions, okay? And I want you to look at the type of inventions that these people got the Nobels for, okay? And Lippmann discovered a method, okay, for color photography. So he did some fancy stuff with color photography, and because he had this new method, he got a Nobel for that. Does that have anything to do with physics or science? Is that just technology? Keep that. That's the question we're going to get down to as well. Marconi, well known for working on telegraphy. He had a big fight with Tesla. They went to court. Marconi won. Then the United States government, 20 years later, 30, 25 or whatever, in the 30s I think it was, then they went against Marconi because he wanted money for stuff that he didn't do, or at least the government claimed that he didn't do, and so they had a big fight over patents. I covered this other fellow, Dalen, okay? He invented an automatic regulator for use in conjunction with gas accumulators for illuminating lighthouses and buoys. And the question is whether that deserves a Nobel. And again, I just want to mention that he was Swedish, same place where the Nobels come from, who grants them, okay? And in 1912, in fact, he went blind because he did a lot of experiments. One of them blew up in his face, just went blind, blinded him. And so, yeah, the question is whether there were more important inventions than this one. I mean, I mentioned, on the one hand, the Wright brothers, they invented the airplane. 1903, 9 years before, they had already a running airplane, which was certainly going to be used 2 years later, 1914, during World War I. And it developed quite swiftly. And no one ever received a Nobel for anything related to the airplanes. And so the question is whether an airplane is more important or had a greater impact on human life than, what, illuminating a lighthouse? So yeah, a lot of these prizes I think are political, and there I think you see proof, evidence. Okay. 1920, last one in the first 20 years, succeeded in finding an alloy of nickel, okay, and steel, right? That registered almost no change in length and volume as a result of temperature changes. Okay, great. I mean, is that such an important thing for humanity to deserve a Nobel for that? But, and again, these are inventions, and the question is whether the Nobel should be given to science, specifically physics, because it's called the Nobel of Physics, right? Nobel Prize of Physics. And does this fall under physics, inventing gadgets? Okay. And again, were there more important inventions than the ones you just heard? Okay. I think the only one that really, to some degree, had a big impact from those, probably telegraph, right? But even that was changed over time, okay? Because I don't think anybody uses the telegraph per se today. They use, other stuff that's been more advanced. Okay, this is the second wave, and you can see the type of inventions changed. You'll see something changed here, and that's 20 years later, starting 20 years later after the last one was given for some kind of technology, some kind of gadget. The first one was Lawrence, and he invented the cyclotron, which is an accelerator, okay? It's a cylindrical type of accelerator, and the particle goes like in a spiral, okay? So he got it to go in a spiral with magnets, etc. And accelerated down the beamline. So because of that, they were able to use it to study what? Particles. So he got Nobel for his cyclotron. Next guy who gets one for technology and gadgets, okay, things, okay, for the invention of an apparatus to produce extremely high pressures. Great. So we have high pressures, okay. Next one, I covered him, Blackett, for improving, because the Wilson chamber was invented by Wilson. That's why it's called the Wilson chamber. Okay, and so he improved on it. And because he improved on the Wilson chamber in such a way that the mathematical physicists who work, the particle mathematicians, they can accelerate particles over there. Well, this helped them a lot, and they said, now we can see particles, we can see traces, and so on. The next guy, he improved the technique in order to study radiation and nuclear reactions, because he says charged particles moving through photographic emulsions leave tracks that can be examined in the images developed afterward. Okay, so now you can see the trace of a particle, if that's what they're seeing, a particle scraping through a gas, and this guy said, okay, we can take these fellow. He showed that you can take a picture of that. Okay, so that was his contribution. Again, we're talking about particles, we're talking about electrons, we're talking about atoms, ions. Okay, that's where they headed. You can see there's a little difference between the first 20 years to the inventions that started 40 years after the Nobel started being handed out. Glaser invented the bubble chamber, which replaced the Wilson chamber. Okay, he put this gas in there and was able to look at the traces through the gas. And in '92, Charpak for his invention and development of particle detectors. Same thing as the others, but in particular the multi-wire proportional chamber. Okay, so they replaced a lot of this with wires, and eventually was replaced by semiconductors. Okay, so the chambers in which they study particles, or so they think they're studying particles, those have been modified over the years. That's what these guys got Nobels for. Okay. Next set of people, they're interspersed in between, okay, but they worked on microscopes and telescopes. They improved on different types of devices to be able to peer into the world of the small, okay. And so the first guy for his invention of the phase contrast microscope. Second guy, telescope designed to capture radio waves. And the third guy for his fundamental work in electron optics and for the design of the first electron microscope. Okay. It's called a SEM, scanning electron microscope. I use those. I was certified on use of electron microscope. Then they came up with this other one about the same time, I guess, the scanning tunneling microscope. Never used one of those, but same thing, is to peer into the world of the small. Can they take pictures or images or whatever of an atom? Yeah, like through a telescope. Okay, I mean, I use these things. I could see very deep. I never saw individual atoms. Or even arrays, because I worked at a level that didn't require that sort of detail. All I needed to do was identify what particle, for example, had fallen on my wafer, and you have this graph that tells you what the chemical elements of that particle are. Okay, and for that you use a SEM to see it first, to locate it, then you find out what it's made out of, and then based on that you take decisions on what to do. Maybe you got to clean the chamber, maybe you got to clean the pumps that are maybe backstreaming into the chamber, etc. There's different procedures to fix problems in the fab, okay, fabrication area. And so yeah, microscopes help a lot for that. The question is whether that's science. I mean, what are we explaining with this, if that's what science is? If it's technology, well, does technology equal science? Okay, so this is the issue. I mean, you can invent a microscope, great, I mean, or telescope for that matter. Is that science? That's just a tool to help you work in the shop, in the manufacturing area, so to speak, maybe in the lab, okay, if you're a researcher. That's got nothing to do with explaining a phenomenon. Okay? And so these are two different branches, and the question is, do both belong to science? And you got to define science, the word science, in such a way as to encapsulate both of them. Okay? You got to incorporate the two notions somehow in your definition of science. And this is where the problem is, because if you do that, then you're going to include the word technology within science as well. Okay, because clearly invention of a microscope, a telescope, or a cyclotron, or a telegraph, all those belong to technology. Is technology a branch of science? Is it part of science? Is science a branch of technology? This is where we draw the line, and it's important to draw the line, make it black and white instead of gray, because otherwise people start talking in circles. You're talking about science and they're talking about technology, or vice versa. And, you know, again, people have this problem because there are no solid definitions. They have not defined them crisply, rigorously, black and white sort of thing. It's all gray. This is the problem, okay? Okay, next group of people. Again, these are not chronological. Exactly, I mean, they're interspersed. I just pulled them out because they have a similar topic. Okay, that's why I pull these out. Okay, and so here's these fellows, and what do they develop, or what did they invent? Well, John Bardeen, Shockley, and Brattain, they're known for developing the transistor. In the 1940s, I think, right after war, they developed it. By 1956, they got a Nobel, and I think the first one was a bipolar. There's two kinds, two general kinds, bipolar and MOS, metal oxide semiconductor, and I think they developed the bipolar. Okay. Kilby, for his part, invented invention of the integrated circuit. Okay, integrated circuit is many transistors, as well as other things in there. Okay, so it's a array of transistors with diodes and capacitors and resistors, etc., all made chemically. Okay, that's what a semiconductor is. That's what an integrated circuit is. And of course, because of that, they were able to get rid of some of these bigger things, which we still use today. We haven't gotten rid of them completely, but they had these printed circuit boards, which I worked on as well earlier in my life. You stuff these printed circuit boards with transistors, capacitors, etc., and they're used in different parts of the industry, of the electronics industry. Okay, Willard Boyle and Smith, what did they do? They invented an imaging semiconductor circuit, the CCD sensor. And again, that's the one that's used today to detect particles coming from space or whatever. Okay. And the last one was in 2014 for the invention of efficient blue light emitting diodes. And diodes, which has enabled bright and energy saving white light sources. So because we save on light, because they invented some new light emitting diodes, LEDs, right? You get a Nobel for that? Just inventing a little device? You know, you would think that we're straying from the purposes of science. And again, is science technology? Is technology science? Is science about inventing gadgets? That's the question. Okay, the last group of people here that I'm going to cover today, and it's these folks, and they invented just a few things that are not specifically related to any of the other people. And the first one is, if electrons are elevated to higher energy levels with the help of heat and light, okay, so you shine light or heat, photoelectric effect sort of thing, okay, an avalanche-like effect occurs when they fall to lower levels. And these fellows contributed to putting this phenomenon into practical use in masers and lasers. So they worked on lasers. Okay, the next guy, he worked on the hologram, and the last guy there, he got his a couple years ago. And what did he invent? Optical tweezers. Okay, that's what he did. And what did they do? They grabbed particles, atoms, molecules, and living cells with their laser beam fingers. Okay, and the tweezers use laser light to push small particles towards the center of the beam and to hold them there. Okay, so they were able to manipulate with these tweezers. They were able to manipulate molecules and atoms, or so they claim. Okay, and yeah, it's possible, but the question is, those are tools. It's like saying I invented a hammer or a screwdriver. You get a Nobel for that? I mean, maybe in the days of the Neanderthals you would. That would have been, quite an invention in those days. And okay, so these guys are able to push, let's assume, atoms around. Okay, so you move them around. We still don't know what an atom is, what it looks like. Is it an atom an orbiting bead? An electron that goes around the nucleus? Is that what an atom looks like? They don't have a model for the most fundamental of atoms. and here they're giving Nobels for a guy who says, oh, I can push those atoms around. Well, maybe you can. What is it that you're pushing around? Can you draw it for me? And no, what he's pushing around is a little ball. And you say, if he's pushing a little ball, how can that possibly be if the atom, the quantum atom, is not a ball? It's an orbiting bead. And what he's pushing against if quantum has its way, are orbitals. What's an orbital? Many orbits. That's why they called it an orbital. It's where you can find the electron bead somewhere within a certain volume. What's that volume made of? Energy levels? Is that what it is? Is that what the guy's pushing with his tweezers? Energy levels? Orbitals? Some abstraction? So again, we don't have an atom, but these guys are getting Nobels for it, saying, I pushed the atom around. And again, we have a lot of technology and no science. Okay? So we have to define what science is and what technology, distinguish it from technology or from inventing gadgets. Okay, and so here's science. We define it, rational explanations. Physics deals with causes and mechanisms. That's what you have to explain. And in order to do so, you need to do it with objects. Here in this side, we don't do much philosophy, except next week when my, next time around when my son comes in, we're going to have another end of the month review and debate. Okay, so bring your questions. It's going to be real time. And then to contrast this, we have technology. Okay, and here you have a definition of technology: inventing, developing a gadget through trial and error. Okay, that's what it's about. And it's synthesized by Mr. Edison himself. I have not failed. I found 10,000 ways that don't work. And Tesla, who worked for Edison at one time, he had a good way of putting Mr. Edison in the right light. He said, if he, Edison, had a needle to find in a haystack, he would not stop to reason where it was most likely to be, but would proceed at once with the feverish diligence of a bee to examine straw after straw until he found the object of his search. Just a little theory and calculation would have saved him 90% of his labor. Okay? Yeah, in other words, Mr. Edison, apparently, if this is correct, and from his own words, you have to say that Tesla was correct, that that's how Edison worked. He was not an inventor. He was a guy who bumped into walls. And the way he had the time and money to do so, so he put his people to work on bumping into walls until he found the right wall. That's how he figured this out. So it's not like he was a genius in a sense that he thought and understood electricity and said, okay, I'm going to use this filament because I think it's a better material. No, he just tried one thing after another until he finally hit it. He says, oh, finally, I got the filament I need. And we don't use that filament today anyways, but that was the best they had at the time, and so he was able to sell it to thousands, maybe millions of people, and that's how he made his money. But that's different than saying, you know, he sat down and he really figured it out. He didn't figure out anything. In fact, when he died, both him and Tesla, neither one knew what electricity is. And Tesla is famous for saying, you know, towards the end of his life, that someday someone will discover what electricity is, meaning he had no clue.